Now in today's video, I just want to link three things together. So what we have up here is a linear equation, something you're very familiar with, and it's got an infinite number of solutions. There is an infinite number of x and y values that can be substituted into this to make the statement true. What I'm going to do is I'm going to take this algebraic statement and I'm going to represent it here as a table, and I'm going to represent it here as a graph and show that all three things are exactly the same. So this is a rule that relates x and y values together. Now the x value, values from your x-axis, are what's called the independent variable. You just choose any value of x you want to investigate. I've chosen to investigate values of x, -3, etc., -2, -1, up to +3. So what I do is I take each of these values, substitute them into the placeholder represented by the polynomial x, do the appropriate calculations, spit out a y value. For example, I'll start at this end. If I put +3 into here, I have 3 times 3 is 9, 9 take 2 is 7. I'm now going to put 2 into this placeholder. 3 times 2 is 6, 6 take 2 is 4. So again, I'll put 1 into the placeholder. 3 times 1 is 3, take 2 is 1. No surprise for guessing, when I replace x with 0, the result is just going to be the number that's by itself. And then I keep filling the rest of it in. That will be -5, -8, and -11. So each of these 7 values of x that I've chosen produce these specific 7 values of y. Now that's just 7 possible combinations that make this statement true. There are an infinite number of them. This table here just shows you some of them. I'm going to go take this series now of ordered pairs or points and plot them onto a graph. So -3, -11, there, and the rest, -2, -8. Now, without use of a ruler or correct measuring, it's not a bad representation, and you can see that they're making a pretty clear and distinct straight line. The line should go through all the points, just that my inaccurate scale means that they haven't.